Today's session is the first of a three-part series, which will occur this winter. Each session will be on Wednesday from 3:30 to 4:30, once per month, November, December, and January. And this is being sponsored by the Ohio STEM Learning Network, along with various additional sponsors who are supporting the work here at the Voinovich School of Leadership and Public Service at Ohio University. I am Jacob White, and I will be serving as a facilitator for these sessions. Ohio University is the host of the Southeast Ohio Hub of the OSLN, and our goal is to share resources and opportunities for developing partnerships that support STEM education throughout the region and state. These three sessions will not be aligned with one another or connected. They're three separate sessions. You're welcome to attend all three, two of the three, or just one of the three. There is a single registration link that allows for registering for any of the sessions as is of interest and availability to you. Today's agenda will focus on science fairs, particularly aspects of hosting local science fairs. I'll begin with just basic components and tenets of traditional science fairs, including purpose, logistical considerations for planning, and the sharing of resources. The slide deck that'll be emailed to you has quite a few links embedded to various resources that may be of help when you are considering planning and hosting a local science fair. I'll also be sharing some ideas for non-traditional science fair-like events. There will also be an opportunity to interact with your peers a little later on in today's session. So with that, we'll jump right in. If you're like me, when I begin a lesson, I like to begin at the start. I like to share terminology and definitions so that there is common understanding and usage of terms. And with respect to science fairs or science events, there are varied approaches. And today's session will focus on a traditional concept of a science fair. I found two definitions that were very consistent that I want to share, and I want to point out these tenets as components of traditional science fair events. Merriam-Webster defines a science fair as an event at which science projects created by students are shown and often judged for prizes. A secondary definition is that a science fair is a typically competitive exhibition of science projects, usually prepared and presented by school children. A similar definition was provided in a research article I came across regarding impacts of student participation in science fairs. This was from the California State University at Northridge. A very similar definition. Science fair being an opportunity for students to apply the scientific method to conduct independent research, where student results are displayed, students are interviewed to determine scientific merit, and students are judged to have used the scientific method properly, and if so, are awarded prizes and have the opportunity to advance to compete in additional science fairs. Larger fairs at a regional, state, national, or even an international level. Within these definitions of traditional science fair, I want to point out important components because I'll stress that these are traditional, whereas there may be opportunities and interest for you to consider non-traditional approaches to offering science events for your students. But in the traditional sense, science fairs are independent research projects conducted by students. The student results have a display associated with them or an exhibition of their results. The student projects are judged and awarded prizes, and the events are intended to allow for advancement for further competitions. Now, this is a traditional sense of a science fair. If you're considering planning a local science fair, it's important to keep in mind these facets as they can link to subsequent science fair events. At this time, I'm going to pause, and using the traditional definition for a science fair, I'm going to launch the first poll. Mackenzie, could you share with our attendees today poll number 1? This poll simply gauges the attendees joining us here today. What is your level of experience in hosting local science fairs using these definitions? Little to no experience, some experience, or a seasoned veteran of science fairs? Okay, we thank you for completing the poll. Again, your responses are anonymous, but it's interesting to share the results. So today our attendees have mostly little to no experience, but interest. And then a few of the attendees today have some experience. Well, this is great. I'm hopeful that what I present today can be of interest to those just starting out hosting local science fairs. Those of you who have some experience, there may be resources or insight that I share that can help spur additional creativity or additional ideas for your next events. A question that I often get from teachers with respect to science fairs is, are science fairs curricular or extracurricular? Well, they can actually be both. It depends on how you host the events and what your intention is. Technically, science fairs, if defined through the traditional tenets, align with the Ohio Learning Standards for Science, particularly the component of the science standards called the nature of science. Here is an example of the K2 curriculum and the nature of science component within that grade band. There is one part of the nature of science called scientific inquiry, practice, and applications, which really encompasses the spirit of what science fairs are supposed to provide in terms of an experience for students. Applying knowledge of science content to real-world challenges, planning and conducting simple scientific investigations, employing the usage of equipment and tools to gather data and extend the senses, use data and mathematical thinking to construct reasonable explanations, and to communicate with others about investigations and about data. This tenet of the academic learning standards fully aligns with the intention of science fairs, and therefore hosting a local science fair is indeed part of the state's science curriculum. I want to also point out that the Ohio Department of Education has indicated that this nature of science section and the application of science and scientific inquiry will be incorporated on state assessments in science, including the state assessments at grades 5 and grades 8. There are many potential learning benefits for students who participate in traditional science fairs. Participation in science fairs presents very clear learning benefits to students. These are just some examples that I feel are directly aligned to the spirit of a science fair event. And it is the specific learning benefits to students that should be driving your planning for both if you host a local science fair as well as how you host a local science fair. Just some examples of learning benefits is that science fair projects can provide students with practice doing science as an inquiry process and as an application. It allows students to take their own measurements using tools and instruments for obtaining measured data. It gives students the opportunity to practice analyzing data and creating data visualizations to communicate the results to others. Science fair participation can also provide students the opportunity to extend their understanding of scientific content that may be of unique interest to specific students. You've probably had students across the spectrum that have varied interest in different fields of science. You don't have the opportunity to devote a lot of your class time to addressing. Science fair projects can give those students that opportunity to really dive deep into areas of science that they have their own unique interests in. Science fairs also provide students increased opportunity for communication skills. If science fair projects allow for teamwork, that communication skill can extend into various team building and social skills on top of direct communication of results as verbal presentations or written reports. In addition, I also find that science fair participation can provide students the opportunity to develop their own drive for learning, and in doing so, further develop a sense of self-efficacy, self-confidence, and also metacognition skills, learning how they learn and learning how to gauge the extent to which they have learned. Science fair projects are uniquely suited to impress these learning benefits onto participants. These are just some examples, but I want to emphasize that it is learning benefits to students that really should drive your reason and your purpose for hosting a local science fair. There are certainly many local logistical considerations for hosting a local science fair. In this session, I'm going to share insight from my experience regarding logistical concerns, and I'm going to do so following the structure of what's often called the Kipling method, or you may have heard of this 5W, 1Hs: who, what, when, where, why, and how. I'm simply following this structure for continuity and flow of today's session, although in reality, there's certainly a lot of overlap in these logistical considerations. I also want to stress that there are not necessarily definitive approaches to the logistics of hosting a science fair. You should find what works for you and your students. That will vary across schools and across districts. If you have limited experience hosting science fairs, I'm hopeful that the examples and some of the insight that I share today can be of direct help to your planning. But if any of you today have considerable experience hosting science fairs, please feel free to post in the chat additional examples beyond what I share, or insight that you can offer to your peers joining us today based on your experiences. Regardless of your level of experience, I'm hopeful perhaps some of the examples shared in this session can spur new ideas for how you host your fairs. I'm going to revisit each of these logistical components one by one in just a few minutes. But first, I'm actually going to jump ahead quite a bit and consider why planning backwards might actually be helpful to you when considering how to host a local science fair. Local science fairs can align with larger events. In the state of Ohio, those events are managed by the Ohio Academy of Science. Local science fairs are allowed to feed into larger events on a district level. Those are referred to as district science days. Those district science days occur across the state, typically in March. And those district events will feed into a larger state science fair event called the State Science Day. These events are managed by the Ohio Academy of Science. They have regulations, expectations, and logistical concerns that would warrant, if you're planning a local science fair and you want your students in your fair to be a part of this broader system of events, it may be helpful to actually plan backwards to ensure that your local science fair is aligned with these larger events. In the state of Ohio, The Ohio Academy of Sciences has divided the state into 17 districts. Each district represents a grouping of several adjacent counties, and each of these districts hosts a district science fair. Students in grades 5 through 12 are eligible to compete at the district level, and the Ohio Academy of Sciences manages the event such that there are awards and college scholarships tied to these events that students actually can compete for. These events are held in March, which means if you're planning a local event and you want your students to be eligible to then participate in a district science fair, your local event should probably be held by January. It could be held earlier than that, but if it is held by January, you'll have sufficient time for students to register and prepare for the district level events. It can be helpful to consider the district guidelines when planning your local events, because if your local events ensure student alignment with the district expectations, it can ease with the student transition or matriculation to the district level events. The Ohio Academy of Sciences has provided quite a few resources available to teachers to help in this regard. One resource is linked here in the slide deck. This is a document, teacher guidelines for hosting local events. And this document has 4 helpful sections to it. One is an overview of educational value to students in participating in science fair events. There are quite a few examples in addition to those that I highlighted a few moments ago. There is another section on student project expectations, or the final deliverables of what students will have to do at the district level. A third section is tips for how teachers can guide students through independent research projects. And the fourth section includes keys to implementing local science fairs to ensure alignment with OAS guidelines. Just overarching keys and examples of important considerations as a checklist. When you receive the slide deck for this session, there is a link immediately below this, this document image in the slide deck that will take you to the teacher guidelines. An additional resource that the OAS has developed and provided to help teachers plan for local science fairs is a turnkey Google Classroom. This was recently developed and made available. This is a local science fair management tool that can assist teachers in implementing their own local events. It's fully turnkey. If you have experience using Google Classroom within your school, this may be fairly easy to adopt. The link that I have included here in the slide deck will take you to the OAS site. To access the Google Classroom, you simply have to provide your information, submit that, and you'll be automatically enrolled and have access to that Google Classroom document. Again, it's a checklist that can help for management purposes, implementing the local science fairs. This is not a mandatory tool. So if you want to host a local event to be aligned with the district or state level guidelines, this tool is not mandatory. You don't have to use it, but it may prove quite helpful, certainly for management purposes as a checklist for students. I also have some specific information to one of the districts, a district that our university hosts. Ohio University is the host institution for District 12. This district level science day is scheduled for March 19th, and students from schools in Ross, Jackson, Vinton, Hocking, Meigs, Athens, and Morgan County are within District 12 and eligible to compete. That's here in the southeast region of the state. This district science day has been announced as being a hybrid event. So this year, students will have the discretion to choose if they want to participate and compete in person on that day, or they can compete remotely through a virtual link. That virtual link will be live. In past events that have been virtual, they've been some of the events have been asynchronous. For the District 12 event this year, students can connect remotely, but it will involve live remote judging at the district level competition. In the slide deck here, I have a link to District 12 eligibility registration. There are various forms for students and teachers, as well as several helpful science fair videos that can help you with planning your local events, getting students started in formulating a project idea, generating a hypothesis, planning out an experiment. These videos and resources were developed by the District 12 director, Dr. Natalie Cruz-Daniel. And again, the link to those resources is provided here in the slide deck. In addition, there is also a mentorship opportunity that I would like to share for students also in the Southeast region of the state, but not specific to District 12. We actually have an external sponsor who has provided support to allow for mentorship of any students in schools within a 4-county region in Ross, Jackson, Pike, and Scioto counties. If you are a teacher or you have a colleague who teaches in a school in one of these 4 counties, please be aware that we can provide mentorship directly to students or directly to teachers who are preparing to host a local science fair. We want to provide that support and help students to compete at the local level and prepare for competition at the district level as well. If you have interest in this mentorship opportunity, please contact Dr. Cruz. Her email is listed here in the slide deck as well. That mentorship can be remote. We can connect virtually, or there may be an opportunity for in-person mentorship as well. At the state level, the pinnacle event or the final round of science fair competitions is referred to as the State Science Day. This is typically held at Ohio State University each year in May. The state level event also has significant prizes, awards, and college scholarships associated with them, some of which are externally funded by sponsors. And those awards vary by project type or content area as well. The State Science Day is just the extension of the local to the district to the state level as a final event for Ohio students. This year's State Science Day date and details have not yet been announced. You can access the Ohio Academy of Science State Science Day website linked here in the slide deck. Details will be announced soon. It has been announced that this year's State Science Day will be online. It'll be a virtual event only, and the judging and competition will be conducted remotely. The State Science Day guidelines, also some additional helpful videos for teachers or students who have an interest in competing in science fairs, as well as printable instructions that can help guide that process are linked here in the slide deck. I also want to share one additional next step in the process if you have interest in aligning your local fairs with these broader regional events, and that is the International Science and Engineering Fair, acronym as ISEF. Our local district, our area district science day here in Southeast Ohio, District 12, we are an ISEF eligible event. And what that means is that we will be nominating one of our projects this year to compete in the International Science and Engineering Fair. The ICEF 2022 this year is also a judged science fair competition. It's scheduled for May 8th through the 13th. It's a hybrid event. The in-person activities will be held in Atlanta, Georgia, but students can connect remotely for participation at the international level. I want to recognize one of our local science fair participants from this past year who competed in the District 12 level, Junu Park, a student at Athens High School. He was our 2021 nominee from the District Science Fair, who then competed in the International Science Fair, and he placed third. He did fantastic. It was such an honor to work with Junu and to see him awarded at the International Science Fair. His project was in the plant sciences, and I hope he can serve to inspire others from the region and elsewhere in the state to believe that they can compete on the international stage. More information about the International Science and Engineering Fair can be found in the link included here in the slide deck. With that, I want to pause for just a moment and ask if you would please answer poll number 2. Mackenzie, could you share poll number 2? This is simply asking, what is your current intention for hosting a local science fair? Are you definitely planning to align your local science fair with other competitions? Are you definitely not planning to align your local fair with other competitions? Are you definitely planning to host a local science fair, but you're unsure if you're going to try to align it with next events in a sequence? Or are you not yet sure if you're going to host a local science fair at all? Okay, I'll give you just a moment answer and then we'll share the results. Okay, the results are in, and most of you are planning to align your local fairs with subsequent events. Some are unsure. It's quite all right. I hope to share some insight that will be of interest to all of you, regardless of your intentions. Thank you for sharing your intentions at this point. So I have just spent quite a bit of time jumping ahead and planning backwards. Well, that could be helpful if it is your intention to align your events with the expectations of district, state level, or even international science fairs. I should mention the International Science Fair guidelines were adopted by the Ohio Academy of Science. So the district and state level events in Ohio are very well aligned for students to compete in the international fair. It can be helpful to think ahead and plan backwards if it is your intention for hosting a local event to ensure your students are eligible to matriculate to larger competitions. But there are certainly important logistics to consider at the local level. And the logistics at the local level are probably of greater importance to you, certainly as you're planning and considering how and when to host the local fair. I want to offer my comments and some shared experiences that I've had on each of these 5W, 1H components: who, what, when, where, why, and how of hosting a local science fair. And I'm hoping that something I share here can spur creative ideas for you to consider. As I go through these, you will notice that there is quite a bit of overlap between these logistical considerations. Again, those of you joining today who are seasoned hosts of local science fairs, please feel free to pop in the chat with additional insight or resources that you can share based on your experiences. So I'm going to go through these one by one. Who? When you host a local science fair, what students do you want to participate in your science fair event? What's important to recognize and believe that all students can benefit from participation in a science fair event. When you're planning your event, consider, is it just going to be you, your class of students? Is it going to be a grade level? Do you have other science teachers in your grade level that you would like to collaborate with to host a local event? Do you want your event to be school-wide? I have experience judging and collaborating on quite a few middle school science fair events. This school-wide. We have students participating at each of the grade levels within middle school, and also that's a common approach for high school science fairs. At the elementary level, more common is that it is a single grade 5 level event. That's not mandatory, but if the intention is for your event to be aligned with district and state level events, the lowest grade eligible to compete in the next events is grade 5. I have also engaged with district-wide events, not just a single school, but all schools within a district. When considering what guidelines you have for your students, think through the final deliverables, project types. If independent research is required, which is the case for traditional science fairs, you may want to consider emphasizing the intention for the project to lead to new knowledge or discovery, not to be a demonstration of science or a demonstration of theory. I see that in a lot of local events. Students don't understand the difference between demonstrating science and conducting independent research to generate new knowledge. Also, consider the purpose and importance of utilizing lab notes, field notes, or journal entries. That is a required component of the district and state level events. The best advice I can offer is to be diligent in note-taking and to have your students write in complete sentences when they take their field notes. Scribbling down numbers only can end up being impossible to interpret several weeks after the fact. And I see this quite often with students, that their understanding of what a field notes and journal entries are is lacking. My advice is to encourage your students, when they take notes as part of their experimentation, write out their notes in full sentences so that they can interpret clearly what they actually did and recorded at a later time. You should also consider what do you want students to deliver? A formal report, a visual display? Will they be giving a verbal presentation? Will they be interacting with judges and expected to engage in question and answer session? These are all considerations for you as you plan a local event. The time frame when to host a local science fair depends on your purpose. Local science days should be held by January if you want students to matriculate into a district level science day event. District science days are held in March. You could also consider, do you want your local science fair to be held during school hours, after school hours? Could it be conducted in a virtual setting? And if your intention is not to have your local event feed into a district level event, then you could have your local science fair any time of year. These are all considerations to help with planning. The location of your science fair is an important consideration. If your fair is to be held online, there are several platforms you could consider. Probably the best platform will be what your district uses for online instruction. Google Classroom certainly is a common platform. If the event is to be held in a physical location, I have seen science fairs held in each of these locations. A single classroom for small events, hallways in schools, school libraries, cafeterias, gymnasiums. I have seen local science fairs held at community centers, held in the gymnasium of local community colleges. Also at public libraries. There are many opportunities for locations to consider when hosting a local science fair. Of these considerations, why is certainly the most important. I've commented on the other considerations, but absolutely the why is the most important logistical consideration for hosting a local science fair. What is your purpose for hosting the local science fair? Some examples of why you could consider hosting a local fair are listed here, but this is certainly not an exclusive list. All of the other plans for your local science fair should emanate from the answer you come up with for why. Why do you want to host a local science fair? How to host a local science fair is a lot. It's a pretty complicated answer, but certainly begin with purpose. What is the purpose of hosting a science fair at the local level? And then figure out the how. Articulate your expectations to students with project guidelines and a rubric. Give them that rubric, give them a checklist to work through as very clear guidelines. Consider staging the project process. Here are 4 examples of stages. You could consider each of these as requiring maybe a week or 2 weeks at the most. And the reason I say that, they need sufficient time to conduct each stage of an independent research project. If you give students too much time, you know what they do? They procrastinate, they wait till the very end, and it can be very tempting to not utilize the time that you provide them. I would recommend 1 to 2 weeks per stage. And you could consider the process as first an idea forming, an ideation stage, and a proposal. Within the ideation stage, trying to think of an idea for a project, there are many resources that students can access to spur ideas for science fair projects. A common resource is Science Buddies. It's a website with a list of common science fair project examples. If you use a resource such as Science Buddies, it's great. It could give students fantastic ideas, but emphasize that they should not simply replicate an idea for a science fair project that they found in some repository of science fair projects. They could replicate the project, but they can also do a next step, something new, something novel that leads to new knowledge or discovery. That's an ideation stage. A next stage would be the actual experimentation, which should involve the usage of a lab notebook or a journal entry or field notes of some sort. A third stage after the experimentation is completed is data analysis, generating data-driven conclusions and articulating future research. Science is never finished. There are absolutely endless questions to answer emanating from research. Really good research leads to more research. Encourage your students to articulate what they could do as a next step for future research. And then lastly, a 4th stage that could help with planning is to take their conclusions, use their data to generate visualizations as a communication effort. If you are requiring an exhibition or a display or a presentation, that 4th last stage would involve the preparation of those materials. And for a presentation, it could be quite helpful to allow students the opportunity to practice presenting the results of their study. Well, these are examples of logistics to consider when planning a local science fair, especially if your intention is to matriculate students into larger regional or state level events. There can also be other opportunities depending on what your purpose is for hosting a local science fair event. There may be non-traditional approaches that are better suited for you and your students. I'm going to provide just some examples of non-traditional fairs. Certainly begin with purpose. Identify what you want your students to get out of the experience of the event that you're going to host. Determine your own capacity and the capacity of your colleagues that you want to collaborate with. Come up with an idea and pilot it. Just give it a shot, try it out. If it is possible that the event can become aligned with Ohio Academy of Science events at the district or state level, work towards that alignment in subsequent years. But go ahead and pilot your idea a first time, see how it goes. Be creative, come up with non-traditional ideas. In my mind, science is not inherently competitive. There are actually some drawbacks in trying to define science as being an exclusively competitive endeavor. Science doesn't have to be competitive. It doesn't, your science event doesn't necessarily have to involve empirical research. If you want your events to align with district and state level events, certainly they need to adopt those traditional guidelines. Here are a few examples, just to spur some ideas for non-traditional science fair-like events that are not necessarily aligned with district or state level OAS competitions. One idea is to offer a Nature of Science showcase. Science fairs are pretty well aligned with the scientific inquiry, practice, and application component of the Nature of Science. But another example, Science is a Human Endeavor, is a second component to the Nature of Science section of the state standards. An idea you might try out is to showcase different scientists. Have students pick a scientist and highlight their background, their life story, their scientific accomplishments, the importance of their particular discoveries. And in doing so, you could emphasize that science is for everyone, and anyone with an interest in science can pursue that as a career opportunity. The third component listed here within the Nature of Science, scientific knowledge is open to revision in light of new evidence. You could have a showcase highlighting examples of how scientific theory or models have evolved over time as new evidence has emerged. This one may be a bit more difficult. It may be easier to do as a group assignment, so there are fewer examples, but just one that comes to mind is the evolution of astronomy, our understanding of astronomical science, evolving from a geocentric model to a heliocentric model to a Big Bang theory. And just recently, we had a new discovery of cosmic inflation, which is causing some revisiting to current models. Science is open to revision as new evidence emerges. Just one example of a non-traditional approach. Another example with a resource linked here is a STEM design challenge. This is a process that is sponsored by the Ohio STEM Learning Network. And this year's focus area is on infrastructure and allowing students to imagine a post-pandemic world and come up with a project that can reimagine a physical space or a service that can become more efficient, more equitable, or more accessible. Resources for conducting a design challenge rather than a science fair traditional event are linked here. This will take you to the Ohio STEM Learning Network site with resources for hosting design challenge events. The last event that I have linked here to share is the Believe in Ohio STEM Entrepreneurship Challenge. This is also an event hosted by the Ohio Academy of Science, and it is a competition that is akin to think of a STEM Shark Tank-like event, a business plan or a product pitch competition where students develop their own new STEM product or marketing plan for a STEM product, and they pitch the idea. This is a fully developed program with quite an extensive curriculum, a set of curriculum resources that are available to teachers. from start to finish. If you have interest in helping students create an entrepreneurial mindset, this might be a suitable approach for you to host as a local event. More information about the Believe in Ohio program is also linked here in the slide deck. And with that, I'm going to pause for just a moment. We have about 10 minutes remaining in today's session, and I want to allow opportunity for attendees today to connect with one another. We had past participants of our webinar series express that they particularly appreciated the opportunity to connect with peers from outside of their specific schools through these webinars. And so I would like to pause and allow you to connect with other attendees. And I'm going to ask, please, if you're willing, turn your video feed off when we transition into breakout rooms. Give your colleagues a quick introduction, where you teach, and what level of experience you have in hosting science fairs. Discuss, have you had particular successes or challenges with hosting local science fairs, or are there resources that you're aware of that could be helpful to others in planning local science fairs? We're going to transition to breakout rooms for about 7 or 8 minutes. The breakout rooms will not be recorded. You can share information in the chat, and I am not going to ask you to share back out when we rejoin in the main room for a wrap up. This is simply an opportunity for you to collaborate with peers from outside of your schools and have open dialogue and hopefully productive conversation. So with that, Mackenzie, could you transition us into breakout rooms, and we'll reconvene in 7 minutes. Well, welcome back. I think everyone has rejoined the main room. I hope your conversations with peers were productive. I hope there was a good conversation of successes, challenges, needs associated with hosting local science fairs. I hope there were resources and information exchange occurring in the breakout rooms. I want to reiterate, your conversations were not recorded. Anything you entered in the chats while in breakout rooms will not be captured in the transcript shared out for today's session. We hope that opportunity is meaningful to you. We recognize it can be quite beneficial to connect with peers in a safe setting, share ideas, and hopefully have quite productive conversations. And with that, we're at the end of our 1 hour slot. I hope today's session was helpful and there was at least some nugget shared that can spur creative ideas in hosting local science fairs. I want to provide, in closing, a sincere thank you and my contact information. If you have follow-up questions, needs, or resources that can be shared with others regarding the hosting of local science events, and particularly if you have questions about details of the District 12 Science Day event hosted here at Ohio University, please don't hesitate to reach out. I would be glad to correspond further. Reminder, we have 2 sessions coming up, mid-December and mid-January. Those will also be on a Wednesday afternoon, 3:30 to 4:30. If you're not available, the sessions will be recorded and archived. You can access those at a later time. Thank you so much for joining today, and I hope to see you again for the next sessions. Have a great day.